All right, today we are doing exponential functions. All right. How do we know if something's an exponential function?
I know it.
What? What, somebody said doubles? Okay, good. What kind of pattern is that?
We got S.
Doubles. Multiplication, good.
We got
X is in the exponent, good. Okay.
And the table is faster.
Yeah, if the table increases very quickly. Yep. So exponential functions starts off slowly and increases rapidly or decreases very fast and finishes slow. Okay. All right. It uses multiplication or percents. So if we have a percent in a word problem, that's how we know we're going to use an exponential function. Okay. All right. Our exponential functions are in the form of y equals 2 times 3 to the x. Okay, remember the exponent is our variable. That's also how we know that it's an exponential function. Okay. The number outside or in front is our initial value or our y-intercept. And the number inside the parentheses is the scale factor. What's another thing, word or way to say scale factor? Or what is a scale factor? No, that's the initial value. Rate of change is like for our linear functions. What is a scale factor though? So the fact that this one has a scale factor of 3, what does that tell us? What's it being multiplied by each time here? It's being multiplied by 3. So what does the scale factor tell us? The multiplication pattern. Okay. Our inside the parentheses, or the thing that's got the x as the exponent, tells us our multiplication pattern. All right. If that number is greater than 1, that means our pattern is multiplication and we are increasing. It's growth. All right. If our scale factor is between 0 and 1, so it's a fraction or a decimal less than 1, then it's going down, it's decay. All right. Remember, if it's a division pattern, we don't ever see 2 and then division sign 3. All right, we know it's going down or a division pattern if it's a fraction or a decimal between 0 and 1.
The other thing, I know a lot of my students, especially with the percent, you're in word problems. It's not the percent that tells you if it's going to change. If they give you a percent, it's going to be bigger than 1. It's the word before it. Like if I earn 50%, that means I'm growing. The word earn tells us that, not because 15 is bigger than 1. If I depreciate by 15%, that means it's going down. Even though the 15% looks like bigger than 1, Mrs. Shennick's going to get into what we do with the percent. But you can't just look at the percent number itself and say, oh yeah, that's bigger than 1, it's growth.
All right. So let's take a look at these graphs, these 2 examples. All right, so same sort of situation here. Y equals 1 times 2 to the x. And we have the graph there and we have the table there. What's our starting value or what's our y-intercept? 1. Okay, we can see it on the graph here. We can see it in the table here, but also remember that that tells me my y-intercept, the number in front of the parentheses. Is this a growth or decay exponential function? Growth. And why is it growth? Because the graph is going up.
Above 1.
Because the scale factor is above 1. Okay, and remember this here is our scale factor. All right, so this one was growth. The second one that we have here, y equals 4 times 1/3 to the x. Is this growth or decay? Decay. And what are our reasons for decay? Because the graph is going down. What else is happening? Yeah, our scale factor is less than 1. What's our pattern here? Are we getting bigger or smaller? Smaller. And what are we dividing by each time? How do we go from 12 to 4? Divide by 3. So it's either a division by 3, or you can think of that as multiplying by 1/3.
It's short answer, and it says why is this growth or decay? Saying it's less than 1 is not good enough.
Right.
What do we have to replace the word it's with? What are we talking
What
about?
specifically is less than 1?
The scale factor.
The scale factor.
So make sure you are being specific. Don't just say it or the number is less than 1.
Mm-hmm. All right. All right, so guys, sometimes we have to write the exponential function from a table or from a graph. All right, our calculator is going to help us with that. Very easily, it will give us the entire equation. All right, if we run an exponential regression. All right, so that's where we type and go into stat edit. Type it into list 1 and list 2. But instead of choosing linear regression, we're going to go to 0 and choose exponential regression. Gentlemen, knock it off now. If you need another calculator, go next door, go 2 doors down. All right, so I'm going to do this real fast. Everybody do this with me. Go into stat edit. And type in your table. It did, but it wasn't like loading up. All right, so stat. Edit. Clear out anything that you have. And type them in. Well, we want an exponential function, so find which one you think you see that says exponential. Yeah, 0. All right, so we're gonna go stat, go over to calc, and we want an exponential function. So we're not gonna choose 4, we're not gonna choose 8. Those are both linear. We're gonna go down to 0 for exponential regression. All right, when you get this, 0. Exponential, okay? When you get this, guys, this is the screen that you're gonna see. All right, so we have y equals a times b, and then remember that that caret means exponent of x. All right, so a is my starting value, and b is my scale factor. So when I write this, I'm going to say y equals a, or 1, times 3 to the x. And if you can't remember what an exponential function looks like, look throughout the test. There's definitely going to be exponential functions written out on the test. Okay, just look through it and see if you can't find and pick one out. Okay. All right. And now when we have word problems and we have to create the equation, we're definitely needing the initial value. And then our scale factor, we're going to have to convert that percent. Okay? We're not going to take the percent that's in the problem. We need to do something with it. All right, so let's take a look real fast at this example. Kathy plans to purchase a car that depreciates at a rate of 14.5% per year. The initial cost of the car is $21,000. Write an equation to represent the value V of the car after T years. Who can tell me, first off, what is our starting value? 21,000. That's our starting value. The initial cost of 21,000. Oh, I am up there. All right. And is this going to be 14.5% growth or 14.5% decay? Decay, and what word told us that? Good, depreciates. Okay, that means decay.
Denasia Holmes, please come to the security desk. Denasia Holmes.
If it's decay, is that going to be above or below 100%? No, decay. Below. All right, so you're going to have to do 100% minus 14.5%. All right, and when we do that, 100 minus 14.5 is 85.5%. 85.5%. Now, is this the number that we're going to put inside of parentheses as our scale factor? Divided by 100. Yes, we have to convert it into the decimal. Don't get confused because this does have a decimal in it. All right, just because it has 0.5, remember, it's got the percent symbol. So this is a percent, and we want it decimal form. So we can take that number and divide it by 100. Oops. And we get 0.855. Have I finished the problem now? Have I finished the problem, guys? No, I actually have to write the equation now. So my equation is V, because it tells me V. V equals my starting value, so 21,000. Inside my parentheses is going to be my converted percent to the T. Yep, because it tells me V and T, so I can't use X and Y, I have to use V and T. You will lose points if you use X and Y when they specifically tell you which ones to use. Okay? All right. Now this next question, sometimes they give us the equation, guys, and they ask for us to find out that percent growth or decay. All right, so let's read this one. The function V of T equals 1,350 times 1.017 to the T represents the value V of T in dollars of a comic book T years after its purchase. The yearly rate of appreciation of the comic books is so sorry. First up, when we are trying to find the rate, are we looking at the scale factor or the starting value? The scale factor. So what is the scale factor here? Good. This is where we just keep it how it is. 1.017. All right. What is this as a percent, guys? What's 1.017 as a percent? No. 101.7% multiplied by 100. I didn't hear you. Sorry. Now, is this number above or below 100? Above, and how much above it is it? Good. It is 1.7% above 100. So the yearly rate of appreciation, which means a growth, is going to be answer choice 3, 1.7%.
Wait. Hold on. Oh, never mind. I get
You get it? Perfect. And 100. Yep, to see how much above or below it is. Okay.